Today we are solving LeetCode 1 to sum in Java. This is the absolute legend gatekeeper for technical interview, and it's problem number 3 in our array and hashing playlist. The problem states, given an array integer called num and an integer target, return the indices of the two numbers such that they add up to the target. Look at example number 1 where num is set to 2, 7, 11 and 15 and the target is 9. If we look at the first two numbers 2 and 7, when we add 2 plus 7 equal exactly 9, the target. Since these indices are 0 and 1, we return 0 and 1. Now let's think about brute force. Now let's take the input 3, 2, 4 and the target as 6. The most obvious way to solve this in a brute force is we use a nested loop where an outer pointer, let's say I, checks a number and an inner pointer j scans the rest of the array trying to find a matching complement that adds up to the target. If we do this, we are checking every single pair of number. This gives us a time complexity of O of n square. It works. It completely wastes processing time. If the input array has hundreds of thousands of elements, your program will time out. We need to find a way to solve this by scanning the array only once in O of n linear time. So how do we optimize this? How do we do this in a single pass? Let's use a data structure called HashMap. Instead of looking forward into the array using a second loop, we look backwards into an HashMap to see if we have already encountered the exact partner number we need. We can look at each number, we calculate its complement. The complement is simply target minus current number. If the complement is already sitting in our hash map, it means we have found our match. Let's track number 3 to 4 with a target of 6. So we start with index 0 with the number 3. The complement we need is the target is 6 and the current number is 3. So we want to look into the hash map for the value 3. We look at our hash map. So let's have this as our hash map. It has, we look at our hash map. Is 3 there? No, it's empty. So we store our current number and its index in the hash map. Next we move to the next index. So we move to the next index 2, and we again compute our complement. 6 minus 2 is equal to 4. Is 4 available in our hash map? No. So we store the current number and then its index in our hash map. Then we move to the next index. Now the current number is pointing to 4 and again we compute the complement. 6 minus 4, we get 2. Is 2 available in our hash map? Yes. Boom, we found our pair. We instantly return our current index, which is 2, and the complement index from the map, which is 1. So let's jump into the code. So what we do first is declare our hash map, and then we want to iterate the nums in a for loop, and we try to compute the complement. Target minus the current number. Then we check on an if condition, and what we check is whether the complement exists in our map. If it exists, what we do is we get the complements index and our current index, and basically we return this. Okay, if the complement is not available in the map, what we do is we add the number into the map and we iterate to the next number. Finally, once all the number is exhausted, it means that we have not found any complements, so we return an empty array. The time complexity is optimized to O of n because we are running through all the elements in the array a single time. The space complexity is also O of n because in worst case scenario we might store up to n elements in our hash memory. Now let's run this code. All our default test cases have passed. Now let's submit this. Awesome. All the test cases are passed. If you want to practice this pattern and track your retention using smart active recall flashcard so you can pass your technical screening round, click the link down in the description to join our platform waiting list. Make sure to like, the video and subscribe so you don't miss tomorrow's walkthrough where we jump into level 2 and tackle the two pointer technique. See you then.